Taylor today?
She's on an 8 school trip.
Oh, okay.
They're going to the to water reserve place or something like that.
Oh no.
Is that what it's called for
I think
the
I've
need the
been there.
water?
Yeah, but it smells bad.
Yeah, it's bad. I went last year. It's not that fun.
Yeah. I did that one time.
Sorry. I was texting. Okay, good news.
Oh, that's pretty cool.
Okay.
Oh, don't forget. Oh, no, I know. That was about escalating the stuff they did. Oh, we got journey assignments today.
How do you SUTs work?
Good.
Up,
Yeah.
up, up.
You said very good. Dude, that's good. That's really
Did
you just say you
like
were
how far?
gonna
Don't tell me. Like, tell me
Oh,
that.
that's so good.
When the point Oh, like 30.
Wait, yeah, but 30 is really good.
Which
So
honestly,
your
how
wrist
many
actually
times?
like,
They're like broken.
that's so unfortunate.
My reason.
How long?
I've been using like 4
It's not too bad.
I can think three, you know what I mean?
Oh.
No, like actually.
But this time I didn't have
Yay.
I still got everybody. Except for So.
That's the way to do that.
Yep. So I got.
We're just like inflating numbers.
No, like my math is not great. And my English is not great. But my reading science.
English is the one thing that I'm like, give me in there.
Honestly, like, such a big scale.
Really? I don't know, I feel like it's just the same.
Yeah.
The rules there.
It's like the same age rules.
On this most recent one? Okay, 1 or 2. Okay, I don't get this.
Well, I did it. I'm just wondering if you do it how, but
Because we don't do numbers anymore.
Wait, do you have the same
I'm
comment?
not like 40%.
There was like comments.
Last night, I realized I forgot how to do long division. So I stayed at like 3 minutes. I dedicated my night to relearn long division.
What was like the serial?
No, like I
Actual, like 62 out of 7.
no, or I like really big numbers. You know, it's like it'll take a while, but I should know how to do it. Right?
Oh, yeah, sure, right?
Yeah.
But, I mean, in a test, they won't give you that thing to figure it out without a calculated question, right?
Yeah.
At least they should.
Here, Mr. Townsend, on this one, I didn't have like a calculator that could do integrals. And
That's fine, as long as you set them up, it's fine.
Okay.
That's good.
And on this one, there was, I think it was 16 and 18, where I think you're technically supposed to do them by hand, but they look like this one. But it never really like showed how to.
Well, this one, you could have foiled this,
Oh.
and then done power roll 3 times.
So then,
18, pretty much the same thing, because integrating 16 would just be 16y, and then if you foiled this out, you would have to undo power rule 3 times.
Do you have any extra pencils I could use?
Yeah, you can have one of those.
Oh, is that okay as the...
It's fine for today. Just make sure you practice it at least once because they will throw that at you on the AP exam.
1 times 10 like 1 of 3 sections. You can find K.
Yeah, from the
Now, also, like, there's so many kids, like, good luck. It's not really just a lot of people. Maybe
How do you find PMs?
Yeah, I mean, like,
some of those were screwed. I mean, you can always use
Tomorrow? I did not read that.
The entire act.
The entire act? Are you? How many scenes are there? I'm screwed.
Can I use your what?
I don't know what that one is. Okay, this is your last chance for handouts 102 and 108. If you didn't put those in Google Classroom, make sure your name is on them.
Oh, sorry.
And come turn the physical copies in now, please. You can still do them for late credit if you finish them, but you need to get that in before the next test if that's you. Last call, any others? 3, 2, 1, okay. Alright, first up, I need to remind you guys about the mock exam, not this Saturday, but next Saturday. If you think you are likely to do that, you need to sign up for that on that Google form. I posted it on Google Classroom. It is completely optional. There's no pressure to do it, but if you think you're going to do it, please sign up for that today, because it's like next Saturday, I think. The date's on there. I'm not, Miss Cross is taking lead on that, so I don't know the last date she's going to look at it. That's why I'm telling you that if you think you're likely to want to go, fill it out now, please. All right, you guys have 3 different handouts today. So let's go ahead and get those numbered. One of them says unit review, and that's going to be 111. Guys, class, we need to get going here. Y'all have had 3 minutes to get settled in. So the unit review is number 111. We'll talk about that in a bit. There is a circuit that I'm going to ask you to do part of, which is 110. And there's one that says when you see, this is what you do, part 1, that is 112. So those are those 3 numbered. All right, unfortunately, we have the stuff we need to look at today is a bunch of small stuff. So you need to be paying attention here to know what we're working on and what is expected of you, or you might do some work that you don't have to do. Or be doing the wrong thing and give yourself more homework. So first off, on the unit review, so I still don't have a date for you on our last test, but these are the main concepts. Area between 2 curves, volumes from rotations, L'Hopital's rule, which we're going to review and practice a little bit today, volumes from known cross sections, and of course FRQ practice is never bad. So those will be the last big topics on our last test. Now, of course, I would love if you all practice all of those skills, but realistically, you should probably feel okay about a couple of them and probably need some practice on some other ones. So I tried to, without making you all do 20 more of every single type, I tried to give you, type up some resources. So just looking at one in detail, and you can read the others, but area between 2 curves, where we did the notes in your binder, where you got a bunch of practice of it that should be in your binder, and some extra practice on Khan Academy if you think that you need it. Likewise for volume of rotations, where that stuff should be in your binder, what you can do for extra practice. Okay. Any questions about the setup of that? Again, your test is still not next class. This is an A week, so I won't see y'all tomorrow, but don't wait until the day before the test to start worrying about that. If you know that you're not up to speed on a couple of those things, start slowly chipping away at it so that when the test rolls around, you'll be in good shape. I don't have a date for it yet.
But could it be as early as next Tuesday?
No. I'd have to tell you because today's the last day I see you before Tuesday.
Right, okay.
It's not next class for sure.
Want to make sure.
That's all I can tell you for sure. It could be. That's a week from now, so that would be a week, an extra week to review. I don't think is plenty of time. But on the back of this, we've got an FRQ that I want us to do this one together. And I don't know that I've given you any of these thus far this year, but I've got several of these in this structure that I will ask you to do before the AP exam. Of course, for the AP exam, usually when students take it afterwards, multiple choice is not usually the thing that they're ever concerned about. FRQs are the ones that oftentimes you guys don't get as many points as maybe what you know. So that is a big focus of what we're going to be doing. Now, I try to structure them in this way, so let me talk about the structure so when you see this in the future, you will know how to use it. But if I know when this FRQ was given, I try to only do released FRQs. I'll try to share that with you. Because it's not FRQ 1 or 2, this was a no calculator FRQ. There's a few of them I know the average for. So this one ended up with an average of 3.2. It's got the directions here, and we're actually going to do this, but again, this one we're going to do together. So I'm actually going to set a 15-minute timer in a minute and ask you to give it your best shot on your own. But why 15 minutes?
So much time you get on each FRQ?
Well, on average. So when they give you 2 FRQs, they give you 30 minutes. When they give you 4 FRQs, they give you 60 minutes. So 15 minutes is supposed to be your average, unless you have extended time, of course. So in a minute, I'll set a 15-minute timer, and I just want you to try your best with it. But if this was one I was asking you to do for homework, you would also want to check your answers and score it to see how many of the 9 points you got. So I try to give you a direct link for that. You can make corrections in a different color so that when you look back at this in a few weeks, you know what's going on. You remember what was your original work and what was your corrections. And then, of course, if there's parts of it you just didn't remember how to do and you don't know how to do even looking at the solutions, I tried to link a video that has someone besides me working it out so that you get a little different perspective. So I try to do that for all the FRQs that I ask you to practice because I feel like that should help out the most.
Is the quiz next Tuesday?
I've already answered that several times. Y'all need to learn to listen at the start of class. I'm sorry. Any questions about this? Okay, now, even though this does sound like AP review, which it technically is, one thing you guys need to understand that is one of your 6 FRQs is often very similar to the stuff that we've done in this unit. So this one from 2019, you're going to see all 3 of these topics came up in our last unit. So this is no calculator, and I want you to give it your best effort for 15 minutes, and then we'll talk about what the answers you were supposed to get, where the score came from, see how you compare to the average, and most importantly, try to find a point or two that you think you could get the next time you saw one like this. So go ahead and start, please. And this is the full thing, so if there's more about the question you would like to know, you gotta investigate. I'm not keeping anything from you. All right, time's up. So, a couple things I wanted you to see there is one is 15 minutes is probably longer than you're expecting it to be. Second is I didn't want to give you too much encouragement here, but what I hope that you see that is if you quit with some time left, and then as we look at the answers and how the points were distributed, I hope that you see there is a couple points you may have been able to get if you had just stuck with it a little bit longer or gone back over it before you had fully quit. So my last class said that they thought part B was the hardest, but I think part A is the hardest. But
I think I got it.
okay, so let's see how you did. I want you to actually grade yours. Now, when I take this up for some points, I'm not going to I'll give you a participation grade. So if you get 2 out of 9 versus 7 out of 9, I'll still give you the full points. I just want you to remember where you were at. But again, the main thing is we're looking for growth here. This might be the first time that you've seen one like this, unless you worked on that handout I gave to you early last time. But this is very likely to be one of the FRQs on the AP exam, and is very likely to be the type of FRQ that ends up on your last test. So each time we look at these, you should feel like it gets a little bit easier to you. Okay, part A had 4 points assigned. So let's look and talk about the scoring of this. So this was, okay, if y'all have a comment to share with everybody, please speak up. Otherwise, you're just a distraction to the rest of us. Okay, so 1 point came, this was about area between two curves. Now, something someone asked in my last class that I almost kind of gave away is, how do you know which one's h of x and g of x? Notice how they didn't tell you? You had to think about which one was which. Yeah. So that's how it really was. So you could either plug in a value for x, like x equals 0, figure out which one has a y value of 1, which one has a y value of 4. I don't know. That's probably what I would do. But why did they do this?
Top minus bottom.
Right. If you want the area between two curves, you should always think of it as top minus bottom, or maybe right minus left if it's the other direction. So you should give yourself +1 if you have either this or this. If you set up the integral correctly, if you integrated top minus bottom, you get +1. Okay, then the second point came from, did you just integrate or do the antiderivative of this correctly? So you could have either done u substitution, or you could have integrated it and undone the one step of chain rule, which is not impossible to do, but of course that's a little riskier than u substitution. So give yourself a point if you got that correct. Okay, the third point came, you had to do the antiderivative of all the rest of the parts correctly. So 6 becomes 6x. This doesn't have a chain rule, so you can just raise the power by 1 and divide by the new power. You didn't have to do u substitution or anything. And -2 becomes -2x.
Would you still get the points if, let's say, I distributed it at the beginning before I integrated it, and that integrated each individual?
Distribute this too?
Like I did x minus 1 times x minus 1.
Okay,
got
yes.
that, and then multiply the -2 by that.
Yes.
I'd still get the points for that.
Yes, absolutely. In fact, the real scoring guides that they don't actually share with people are usually 10 pages for the what ifs, because lots of people do things differently. But this is just the main one. So yes, if you foiled this and then distributed it to, and then you integrated those parts correctly, and it's equivalent to this, you still get the points.
I switched out the g of x and h of x, but if I still distributed that and did all the integration correctly, would I still get the point?
My guess would be that you would still get the second and third point if you did all the integration correctly. Okay, but of those three, now this one is a little bit harder because you have to do u substitution. But of these three, these two are pretty much gimmies. 6 is 6x, -2 is -2x, right? Those don't take too much work. So I feel like point 3 is not that bad either. Now, without a calculator, trying to get down to the answer to get the fourth point, 44/3 is a little bit harder, but since one of these numbers was 0, lots of this stuff went to 0, so it wasn't impossible.
You didn't have to simplify it all the way to 44.
Okay, so where did you stop?
Or you could stop it just right before that.
Right here?
Yeah.
That's correct. If you left it like this, you still get the point. In fact, if you left it like this, you still get the point. They don't expect you to do any arithmetic. Now, if there was something like this, and you leave your answer like that, they don't consider that arithmetic. Like, you actually have to figure out what this is, and then you can leave that alone. But it's in your interest, time interest, and just in case you make a mistake, don't do any arithmetic. Stop there. While I'm grateful that you guys didn't do that to me this year because I have to check your answers to see if it's equivalent, that's what you should do for the AP exam. Okay? They don't expect any arithmetic. Even if it's 5 plus 3, you don't have to say it's 8. You can just leave it 5 plus 3. Okay, so before we move on, area between two curves, top minus bottom. Any questions about how the points were distributed or how they did any of that? Yes?
If you made a mistake earlier on in the process and you got an answer correctly through that, what you ever got, do you think you get points for an answer?
Honestly, I know sometimes, like, if you make a mistake in part A and then use that in part B, they don't count it against you. But I'm pretty sure that if you make a mistake in part A and then continued, some of that they're kind of secretive about. So I think sometimes they do and sometimes they don't, is the short answer. I think if they grade it and it's like super low average, then sometimes they come back and say, well, let's be a little more generous and do those kind of things. But they're not transparent with all of that. Okay, but my guess is that most of you guys probably got, what, 1 or 2 of those points? But if you got another one like this, don't you think you could probably get another 1 or 2 fairly easily?
Yes.
I mean, I don't think anything in there is like, it's not easy, but it's given 15 minutes, you guys can do that. All of you can do that. Okay, part B, which is what my last class thought was the hardest, and to me is going to be the easiest. When you do, well, wait till you see the answer and the work. When you want to do volume from known cross sections, that's one of the things you guys turned in. All you do is you integrate what? The area. Now on the handout that you turned in today, you have to memorize some of those area formulas. If it's a or equilateral triangle, it's square root of 3/4 times base squared. That type of stuff, right? This one told you what the area formula was. It's some shape. They didn't even bother to tell you the shape, but they said, here's the formula for area. So all you had to do for part B was integrate the area, and they told you area. So point 1 is if you did this, or if you plugged in a of x. If they defined a of x, you don't even have to plug it in to get that point. Either one of those is fine. Because this is x to the first, this integrates as natural log of x plus 3. Plug in 2 to get natural log of 5. Plug in 0 to get natural log of 3. Yeah.
So like well, I didn't really understand B very well. Like when it comes to the actual verbiage, you know, like the language of cross section perpendicular to the x-axis. Like, what does that mean?
The same thing that you turned in today. When you get a volume from taking two-dimensional shapes perpendicular to either the x-axis or the y-axis, and you add up all those shapes. So integration is a way to add up an infinite number of something. So if the area of those two-dimensional shapes was 1 over x plus 3, integrating 0 to 2 is like integrating an infinite number of those. And when you stack those up vertically, remember when we talked about those pictures and it was hard to see it vertically? That's what it is. All those two-dimensional shapes stacked up vertically make up a three-dimensional shape. So as soon as you see volume, perpendicular cross sections, you should just be integrating area. Okay, so 1 point if you did this or this, either one is fine. And then you get 1 point if you got the answer. Now, you can't stop right here because they're not going to give you that last point. You actually have to know what to do with 0 and 2 and actually show it. Now, this will get you the point, but isn't there another way you could write this? Good. Remember, you can condense logarithms if they're the same type. That's what we're doing, or what we're finishing up in pre-cal right now. So that would work too. That's equivalent, but also it takes more time, and then why run the risk of missing it? Just leave it alone. This is arithmetic, stop there. So, do y'all still think part B is the hardest?
Yes.
Volume from cross sections, you integrate area. Try not to think of it more than that. Try not to overcomplicate it. All right, then last part. What did it say? Set up, but don't integrate the volume from rotating this around the line y equals 6. Does that sound correct?
Yeah. Ish.
Okay, so they gave 1 point if you got the limit, or I'm sorry, the limits of integration, 0 and 2, and you got the constant, which is pi. Remember how I told you pi is one of the more forgotten things on FRQ? But we're adding up a bunch of circles. That's the disc, the washer. Both of those are circle shapes. So you got 1 point if you just got that. Why do they have something squared minus something squared? Right, so if you have it in this form, even if it's not correct, you get the second point. If you have it in the form of something squared minus something squared, you get the second point. So that's showing that you understand the structure of the washer method. Then to get the last point, you have to have the whole thing correct. Now, you don't have to solve it or anything. They said just set up. But those are pretty tough radii to get. They're not harder than what I showed you on the circuit, but that's why you need to practice those harder ones sometimes. Yeah, David.
Where do you get like the 6 minus GX?
I don't know about quick, but
You can do it slow.
okay. What line did you rotate it around?
Yeah, exactly.
Okay, so first off, this is a horizontal line, so that makes it d. Okay, why was it 0 to 2? Okay, that's the far left and far right. Why is there a pi out front? Because it's a bunch of circles. Now, because it's got this gap in area and this gap in area, when you rotate this shape around, these gaps in area create gaps in volume, which is why it's washer method instead of disc method. But if we're rotating it around this line, this one's the outside, so this is going to be the big radius. So from here to here would be the radius, and here to here, and here to here. Well, I just be honest with you. The first thing I'm going to think of is not 6 minus the bottom function. What is something that you guys tried that just didn't work, or wasn't the same thing?
H of x itself.
Okay, so if you said it was h of x, you should test this with a couple points that you're sure about. When x is 0, what is this radius?
5.
Okay, well if I set it up the way you said, if I plug in 0 for x, I would get 6 minus 2, which would be 4. So that can't be the radius. Again, that doesn't help you necessarily get the right answer, but it at least tells you, wait, there's got to be more to it than that. Also, if you just say h of x, what about when x is 2? You said that the radius is -5? That doesn't make sense, right? So what all of these lines have in common is that this length is 6. You could go to 6 and then subtract away where that function is. So in this case, subtract 1. Or you could go to 6 and then subtract where the function is. But subtracting a negative is like adding. 6 minus a negative number adds. So 6 minus, wait, this is the bottom one. When this g of x,
Yeah.
g of x. That's where they're getting 6 minus that. That's the formula that gives you the length of the radius for the outside. If you think something else works, again, I just encourage you, plug in 0 for x, see that you don't get a length of 5. Plug in 2, x equals 2, see that you don't get a length of, I guess, 11. That's what it's supposed to be. Okay, then same idea for, yes,
Wait, if you plug, oh, sorry.
David?
Never mind.
Okay.
If you plug in a 0 and 6 minus g of x, it'd be 6 minus 5, right? Which is 1.
This is a negative 2.
Oh, okay.
When you say 5, it sounds like you're adding 2 and 3. Okay, let's try to look at the same thing with the short one, because this would be the small radius. So sometimes that radius length is 2, sometimes that radius length is 0, sometimes that radius length is somewhere between 1 and 2, it looks like. This one's a little bit easier to see if you try to draw in the cross sections. Doesn't take up quite as much of the picture. I know it's tempting to just say maybe this is h of x or something, but like right here, h of x is 4. It's supposed to be 2. The radius is 2. They're not the same thing in this question. Sometimes it's that straightforward, sometimes it's not. Again, that's why sometimes, you know, I'm sure you're near the end of enjoying circuits, but those circuits build you up to these question types where sometimes your radius length, you have to find it in the same way. So for this one, notice if you took the length 6 and then you subtract away where that function is, you get the right length. Or if you take 6 and then you subtract away where the function is, you get the right radius length. Or if you take 6 and subtract away the function, you're left with the right radius length. So 6 minus that function is how they came up with that. Yes?
Is the best strategy for that kind of like just guess a check, or how do you?
That's what I usually do. I just kind of guess a formula and then I check a couple points and see if it's working out. And then sometimes if it's not, you know, based on what you're getting, you might have a more educated second guess. So.
What would you say is a good score on this FRQ in terms of passing the exam?
Well, the average this year was 3.2 out of 9. So if I was y'all, I would be happy. If you got 4 or 5, I would be happy with that. But you also have to keep in mind that, you know, you can't just say, well, I got a 4, so I'm in great shape. You might score above average on this one, but then the next one you might score below average. So you want to squeeze out every point that you can. But
Wait, could you plug in 1 just so I can visualize what you mean by like checking?
okay, so let's pick one that you know the length of, like maybe x equals 0 has a radius of 2.
Yeah.
So when I plug in x equals 0 into this, what I'm saying the formula is for the small radius, it's supposed to be 2.
Oh, okay.
So 6 minus, if I plug in 0 here, this would come to 1. So 6 minus 4 is 2. But of course, just because it works in one spot, you should probably test it in multiple spots. But
Yeah.
you guys did see some of these on that circuit, right, at the end, where you had to take a length and then take away where the function was? I know there wasn't a ton of them, but that's why it's important that you get all the practice you can. Okay, so most important thing, I'm not concerned about your score on this, but whatever score, go ahead and write your score on your page. So you remember 4 out of 9, 2 out of 9, 1 out of 9, whatever. You need to say, if I saw one like this, not the same functions, not the same graph, but same question types, you need to find 2 or 3 points that you think you could reasonably get. Maybe, you know, obviously aim for all 9, but there should be 2 or 3 that you're very reasonably close to, and that's the type of growth that you need. Hopefully you get those next time, and then the next time you can worry about squeezing out another point. And then if we get to practice this type again, maybe squeeze out another point. As long as you do that, you'll be in good shape. So I think my highest score last period was a 6. Anyone get higher than 6? What'd you get? 8?
I got 7.
All right, which ones did y'all miss? I'm just curious.
The answer.
I missed the answer on A and then like the actual integration on C. Or like the, you know what I mean?
Hold on, I gotta look at the scoring. The integration on A. This.
The final answer on A.
Yeah,
Okay.
doing the meeting too, I messed
Yeah,
up.
I messed up there.
Oh, but did you have somewhere like this at some point?
No, I messed up.
Oh, okay.
I don't know where I'm.
I was gonna say in the future you could just stop sooner and get the point, but
Yeah.
okay. And what was the other one?
I missed like on C the last part. I got the like the pi and the 2 and then the big and little, but I didn't get the actual like 6 minus. That.
Okay, so the radius. Yeah, that's the hardest part for sure. Okay, good. So I think that was a good learning experience. 15 minutes is a lot more time than you guys think. If you had extra time at the end and you quit, I bet you there was a point or two you would have gotten if you had stuck with it, which of course you need to do on the real AP exam. And now that you've seen this and learned from some of your mistakes, I hope that you feel like you could get 2 or 3 points without a ton of extra work. Okay, so we have talked about the review now. You have that completed. Let's go ahead and skip on the agenda to number 112. When you see ... this is what you do, part 1. It's called part 1 because I've got several parts of this. So this is not exclusive to our last unit. This is really more AP review. I don't have a digital copy. But, of course, one of the hardest things, whether you're talking about multiple choice or FRQ, is just remembering that when you read, it's this type of question, what am I supposed to do to start off? So, looking at the top row there, if you were given velocity and you wanted to know change in position, also known as displacement, remember that we integrate velocity to get the change in position. That's what's listed over to the right. You remember when it's that type of problem, that's what you do. And then the next one, given velocity, if you want the total distance, you remember what we did differently? Absolute value. And you see how that's listed out to the right? So these are all things that you will see on the AP exam. So one piece of your homework is I want you to read through these. I hope that you remember them all, but if there's some of them you don't remember, put a star by them and study them. I'm going to give you a short matching mini quiz, and it will be just these, and they'll be typed up exactly the same way. So if you don't know, if you don't remember some of these, this is this type of problem, then I need you to study that between now and next Tuesday.
Next Tuesdays.
Next Tuesday.
Mini quiz Tuesday.
Yes. Now, there will be a part 2, and I'll probably give you a mini quiz on that as well, and it might include a question or two from part 1. So again, I know it seems like the AP exam is a ways away because it's in April, but again, by the time I think we lose 1 day for ACT Aspire, you're going to lose a day or two, maybe taking other AP exams, to lose a day when we do our last unit test. You start subtracting all those days away, it's time for you guys to start filling in the gap. So if you're doing what I ask you to do, then I will make sure that you are on pace to feel comfortable for the AP exam, but please don't procrastinate that. Okay, and then last thing that we need to do in class, so we need to review L'Hopital's rule. I showed this to you first semester when we had some extra time, but it actually falls in this unit, and so you should expect a question or two on your last big test about this. So I'm not going to say anything new. I just never held you to it from an assessment. But I want to do a few of these with you and as examples, and then I'm going to ask that you do at least half of the rest of this. So I'm not insisting even that you finish all of this one. Of course, I encourage you to. More practice is always good. But I think you'll get the idea from doing some of these. Okay, the nice thing about L'Hopital's rule is that it often helps you with limit questions. And I know limits is the most furthest removed thing that we have. So it gives you kind of a new tool. Occasionally on the AP exam, they'll ask questions like this one, where your only option is going to be L'Hopital's rule. But there's also questions like this that you can do with what we did the first 2 weeks of school, but you can also do L'Hopital's rule. So what L'Hopital's rule says is if it is an indeterminate form, 0 over 0, or plus or minus infinity over plus or minus infinity. Well, before I tell you what L'Hopital's rule is, before I remind you, do you remember the very first step in trying to solve this without a calculator? Okay, plug it in, direct substitution, and do you see that the numerator goes to 0 and the denominator goes to 0? You remember that? Okay, well, we had to do the first couple weeks because we didn't know derivatives, is we had to make this look different and get something to cancel out. So there was lots of different algebra tricks we could do. Do you remember what the most common trick was? Factor. So if I factored this, you don't have to write this on your paper, by the way. I just want to show you the connection. If I factored this, what happens? Okay, and then what do you do?
Isn't there a hole in minus 3?
Then you plug it in.
There is a hole at -3, but limits don't care about that. Limits are not the same thing as points. Okay, then you plug it back in and you get an answer of
-6.
okay, and that's still fine. When you, not if, but when you see this type of question that you can do factoring on the AP exam, you can do it that way. And I'm not even going to say L'Hopital's rule is even easier on this question. But what L'Hopital's rule says is if, it's a big if it's an indeterminate form, you can do this instead. So it's just an option on this question. You can take the derivative of the numerator, which would be
2x.
then the derivative of the denominator, and then you can try direct substitution again. If it's still an indeterminate form, then you have to take the derivative of the numerator over the derivative of the denominator again. Now note, this is not quotient rule. I'm not taking the derivative of the whole thing at once. It lets you just take the derivative of the numerator, derivative of the denominator, and then try direct substitution. So is that faster on this question? For some people, maybe. It just depends on how quickly you see the factoring, I guess. But that's all L'Hopital's rule says. Now, let's scroll down and look at the next box. I guess there's no big secret here, but this is supposed to be question number 8. If they ask you 1 or 2 of these on the AP exam, this one you can't do like we did the first few weeks of school because you don't know what F is, you don't know what G is. You can't just make this look different. You can't be creative with algebra, get something to cancel, and then do direct substitution again. But, I don't know, what shall we start with?
Plug in 3 in.
Okay, plug in 3. What is F of 3? Okay, so the numerator goes to 0. What's G of 3?
0.
So we get 0 over 0. Don't say equal 0 over 0. You can say arrow 0 over 0, but not equal 0 over 0. Then you realize there's no arithmetic, no algebra, no factoring, no complex fractions, no trig identities. You can be as creative as you want. You're not going to make this look different and not be an indeterminate form. But what L'Hopital's rule says is, well, wait, why don't you try it after you take the derivative of the numerator, which would be what?
F prime of x.
Okay, which ends up being -6, over the derivative of the denominator, which would be G prime, which ends up being
12.
And as long as you don't have 0 over 0, positive or negative infinity over positive or negative infinity, you can assume that that's your answer.
Or does that go over to?
No, because when I took the derivative of this, the derivative of that goes to 0, so it doesn't matter anymore. Okay, I would like you to try. There's one I want you to try before we go over, and that is the one on the bottom right down here. It's actually number 3. I guess that makes sense. Well, we didn't do number 2, but I actually want you to try this one. We'll go over it, and then we'll do one more as guided practice, and then so that will be 4, and there's 22 on here, so you can pick out another at least 9 more, and you can pick and choose.
Turn these in and start class.
Yeah, it'd be late. Well, this one's not finished. Late work needs to be finished. What do you need?
That was really nice. I still need that.
You gotta wait for the pass. Okay, I gave way more than enough time here. So first off, do you guys remember how to do this from earlier this year? Something about this made it a certain type of question. Okay, that's how you get the answer, but the far right and far left of a graph is what in math we call horizontal asymptotes. Remember the horizontal asymptote rules? If the degrees are equal, your horizontal asymptote is
The constant from it.
it's called coefficient, but yes.
Yeah.
Leading coefficient over leading coefficient. So that's fine if you remember those rules. But if you forget those rules, you can try direct substitution, see that you get indeterminate form. You can take the derivative of the numerator over the derivative of the denominator. Try direct substitution again. There's no x's. So your answer is 3/2 either way. But you need to see it gives you options at least. If you forgot how to do the other part, you've got kind of a backup plan. So sometimes it's needed, like the second one we looked at. Sometimes it just gives you alternate path. Or if you just think it's easier, it's fine too.
Wait, for limits, what makes it a vertical asymptote?
Vertical asymptotes when you try to divide by 0. So like 5 over x is going to look like this because it doesn't exist at 0.
Yeah.
So it's going to have that vertical spike in the graph. Okay, I've got one more for you. I would like you to try this one on the back, the one that says answer 2/5.
Which number was that? 2 bits, 1 is 6.
Yes, it ends up being card 6. Okay, I'm guessing for card 6, somebody got an answer of 6. See 1 yes, 2 yes, 3 yes. Is that a yes? The answer is not 6. This is why it seems random, but this is why I picked this one. You can't do L'Hopital's rule every time. You can only do L'Hopital's rule if it's an indeterminate form. You have to make sure it's an indeterminate form first. If you plug in 3, you get this over this. Negative 27 over 9 is not an indeterminate form. Doing L'Hopital's rule when it doesn't apply misleads you. You can't just assume that that always works. It has to be indeterminate form first. Now, to be honest with you, I made the same mistake, so if you're not careful, but it only works if it's indeterminate form. If it's not indeterminate form, L'Hopital's rule is going to maybe think that you have an answer other than what you really have. Okay. So again, there's like 22 of them on here. We did 4 together, so if you do half the rest, that's half of 18, so at least 9 more. Of course, I encourage you to practice all of them, or if you don't feel like you're super confident after doing any 9 of them, then you should probably do more and possibly come see me during advisory to help me get you caught up. So before I walk around and help out individually, the things you need to do for homework is, well, first off, finishing half this circuit I think you should be able to do in class, so I'm not considering that homework. You need to make sure that you review 112, the when you see this is what you do part 1, and make sure that you can at least do a matching quiz on that for next class. Should be easy points, but you may not remember a few of them. And the unit review 111, even though your test is not on Tuesday, if you know you're not ready for some of those questions, then you might as well start preparing for them. Don't wait until the middle of next week, possibly when you've got a bunch of other stuff going on. Okay, so go ahead and start finishing up the circuit, and I will come around and help you with your questions in just a moment.
Okay, that's the so yeah, and then you do the chain order. Is there
You sure? Are you sure, Harrison?
I mean, yeah. Because we already did it.
Harrison, are you sure?
I accidentally wrote
He looked it up.
So I'm not sure.
I got
The answer is yeah.
So Harrison, if you want to scrap right now, we can.
How do you do that?
I don't like to look on your phone.
No, so you see that squared and then the x is 5x.
So times 5 divided by 1. Oh, well, technically squared. Yes, sir. Squared.
So it's going to be 5?
That's it.
Jeff, how do you do this?
Yes, you have to do it. So if you do it once, it's still indeterminate form. You do it a second time. And maybe a third time. One of them you might have to do like 7 times if you do it. I don't recommend it. I don't want to give it away.
She might be like spreading it.
On that one, I can tell you I think it does. 3 times before L'Hopital's rule works. Essentially what you're doing is, like, in the big grand scheme of things, like as X goes from really big, like infinity, this grows quickly, but nothing in comparison to that. So by taking the derivative, you're like simplifying the rate to try to figure out which one's growing faster. And what, like, in comparison to the other.
Yeah.
treat it like an X.
Wait.
It's something for like a temporary
Awesome.
Yeah.
Oh, wait.
I'll
But it doesn't like kick in right away.
I got it.
You're doing your final score.
What's the derivative do?
Gotta go right by thing.
Right? So whenever that number.
Really? I
Oh,
don't
right.
You're gonna argue that. No, that's.
Good.
So that's
Did you say pro women?
since you're proud, right? It looks like something like this is gonna show you.
I'm gonna say they're environmental benefits.
Okay, well,
No, because like the erosion, like here is erosion in
Like, what if they like fell on someone? What's it called? What's it called?
Well, if it was like something like this, then yes, you can. I'd assume like some, I don't know.
Windmill fast.
Nothing crazy. You're
Oh,
gonna
yeah, it's my and yeah, I think this one.
Wait, this was going to be the source.
That's like -3.
I know.
I'm assuming you have problems with
I am
that is
I have 3
Number 5. Yeah.
Where's the?
on that road.
Number 6 is
Things you didn't know about wind power.
I got 3 over E.
Oh,
over -1.
I like that part.
Oh, yeah, I agree with
I'm just gonna address that counter argument. Try to get that.
It's just negative.
I didn't know. Although it should be considered like they are.
Basically, I failed that.
Divide, stay with actual 5. You change the divide out from secant squared at 0.
I had one twice.
Yeah, you should do
Three
one. There's one that's like, dude.
But what's the limit?
Yeah, you do.
H minus.
What is secant squared of
Yeah.
0? What's secant?
Yeah.
Wait a minute, hang on.
Secant of 0.
It did
Here
fly.
somewhere.
If you plug it in, you can have one.
So 1 times 1 times 5. Mr. Townsend, so where was there? Zero, one,
Jeff, you
yeah.
You got a 4 out of 9. You're not close to it.
Well, look, I missed the bounce. I had the right answer figured out, which is perfectly correct. Alright, except for. I said I was close, I didn't say I got it right.
I didn't even touch the version.
How did you do?
Because I looked at it like this and I just looked at the one in my mind and if you do it without running for officer, you do get elected. You don't have to listen a little bit. I was trying to figure out this.
It's a lot of work.
What's the
I know
difference?
the best person of hours. It's the highest you can do without doing any work. I didn't have.
I'm still at home.
Alright.
Well, the derivative of e to the x.
I'm just gonna check my.
Well, not really.
E to the x is
Except that's 1, so we don't have to keep up. So if it's something else, like 3 to the x, your derivative is going to be 3 to the x times the natural log of 3. Okay.
But what if we, okay, yep.
So if you did that, you're going to need a natural log of 3. You need to consider chain rule, but chain rule doesn't apply. The derivative of h minus 2 will just be 1.
Okay, okay.
So it's like 3 to the x times 9. Interesting.
0.
I'm gonna see 0 or does that
It's 3 to the
exist?
h minus 2 times natural log of
So 190.
I got it.
Yeah.
Oh, wait, yeah.
How do you do it? It's an answer.
Four down.
Oh, it's an answer.
Yeah. Yeah. We thought we had to do some more, but then we don't have to.
I did a couple of them, but I didn't do them all.
Sine of 3 pi. Or sine of close. Sine of half. 0.
I didn't even touch the integration.
Why would he do that?
I integrated 6x and then I just wanted to do
What is this mean?
And still.
Yeah, you gonna
This is what I did.
This would be like high level
So basically, so like you would actually consider
Alright.
well, actually, it's actually like you do the x times natural log.
Oh, it's not. Okay, you and Mr. Moss is watching it.
Yeah, and simplifies it to the x. That's why it's like.
No, it's not.
Yeah.
You can't take
Never
the
really got
natural log of x. We're trying to find the derivative. We're trying to find the derivative of one natural log. No, they're not. We're not finding the derivative of one of quotient.
You gotta subtract pi over.
Oh, I know, you're right.
But then -1.
This one, you take a derivative of this, right?
No, cosine.
Yeah, that's integrating.
Yeah.
You're going the wrong way.
Oh.
Okay, so you think of this as x as a negative one.
So like, how does that help?
Okay, X.
It's right here.
You have a question?
It does, honestly.
Perfect scoring.
What do we do now?
Also, you don't have to do these in order.
It does not.
Again, I just want y'all to get some practice. So feel free to skip one if you want. You need to get at least most of these done by the time I do four.
Negative distance. No. 0, -1, -2. Bring it down to negative.
Oh, yeah, you do.
Oh, no, this is your
This would be
2 over -1.
-2. Yeah.
Sample TT.
2 over 1.
Right, this is the derivative of sine 5x is negative 5.
It's a negative pi.
The derivative of sine of something is cosine something. The derivative of cosine of something is negative sine of something.
Oh, okay.
Start integrating those back to
What? I don't know.
What? Cosine cos.
Yes, it's negative.
So you have negative pi over
I just
negative
came home and I've tried to
2.
do myself pulling out of my notes immediately.
No,
Negative
negative
6
9.
times 5 times.
You have negative 5
I mean,
over
yeah, walking my
negative
car and I
2.
just got to the side, I stick it out and
Wait,
started
you
doing
get
it on
2
the
over
ground.
negative squared?
Yeah.
Just in the middle of the parking lot, look at your leg.
I have to motivate myself for it. I have to go somewhere. Let's go to my house. Be good for you.
So did you get 9 pi?
1 over x.
No one's
is negative 1
Actually,
over
you can get
9 pi.
some of that stuff off the screen, like, I swear, it's just a joke, like, it's not that bad.
I was looking at the last one.
Oh.
Yeah.
Reese, it's like negative.
and are you in charge of
I'm
the
taking like 3 classes.
Or
so
negative
it's
X.
like
From?
might as well drop out.
What is
The two should be
Physics C.
Why are you saying, how would you do that to yourself? Oh,
It's like, it's like a STEM trifecta.
Are you
Because I remember that being negative, and I got 2. The 2 should be more, so it's just.
You can find out what you can change it.
That's correct.
You'll be fine the first time.
But the derivative of sine something.
Wait, I don't know.
The thing is
that,
I know it's gonna be a hard class.
is that taking
Is that like derivative?
I'd rather take the basic or let me read every single.
Did it come out?
Something.
It came out?
Yeah. Times the derivative of the inside.
How do you check it?
Okay. So 2 over cosine of that.
I'll give you like 3.
I think it's otherwise.
You'll do really well. Like if you
Not any major ones, but you can get stuff. You can get lost.
Not get it right though.
Not any lost.
You need to go get
Can I get some idea? Start it.
For
Yeah,
down there.
What if I just
They're actually misleading.
Those aren't on your legs. So your braces aren't on your legs. No.
So that would be 1 over 5 over.
Is that 0?
No, would you take the
Does not exist. Is it something? Yeah, no, something's. He's right 9 pi. Just.
I was only supposed to do 9.
Take the power down where the power goes 1. Derivative of times something, cosine something, times y. Your denominator, 1 over x, the derivative of 1 over x is not natural. That's on me. That's on me, actually. That one's my fault.
No, it was my
Integrating 1 over x, it's natural, but not.
Oh, this is correction.
How do you do
Negative 1, so it's negative 1.
Yeah, I don't know that. It's negative 1.
But it's not smooth, but that's negative 1 over x squared.
Yeah, I don't know. I don't know.
You have to rewrite it next one.
So it's like I cosine.
See, it's like y'all could do that, no problem last night, but when you throw in integration and like. Did it just kind of? Yeah, like sine becomes cosine, cosine becomes negative sine, but then the rule.
I don't remember how like take derivatives of like simple stuff.
Like, Miller's gonna do that.
That's the first step to realize you don't remember.
Like I was thinking about what's the derivative of x squared?
But depending on what.
1/3 x.
It took me like 30 seconds to a minute to figure out the derivative.
Because
Like
these are the
pi over 2 is x, and that for cube was just pi over 2. How?
We had to erase it. That's why we have to erase it. How did you? Way faster.
So you just
we have that as not.
Why are they starting so late? When you want someone to wake up at 0 hours, wake up. Yeah. What do you think they do if they see like
I guess you just bring the power down to
From logarithm property, you can bring the 2 down first. And the derivative of natural log of something is 1 over.
Oh wait, this is like derivative.
you think if like
It simplifies to 0 over.
fucking 0.
you have to do what if I was like, I mean, it's just
I'm saying bring in the 2 down as a logarithm
what if I
property.
get one to the head
So
still?
first thing you can do is say it's 2 natural log of x.
No, he's not ready. You know.
No.
He's not ready to lower it. He's not ready.
I guess it doesn't have to.
Exponent on something, you're taking the log x and you can bring it
No,
down.
but I thought it was like the next one of
It'd be the best.
I mean, that doesn't answer all this, but there's probably one other way.
If I actually
and then I would just take the derivative.
Which makes it 2 over
X plus 1.
I got 2
what's the derivative of x plus 1?
I think I actually
I simplified it, so I don't know what we talk about. And then the root of it.
Yeah, but that's you guys.
Why is that? So what I did is, this can be recorded as so divided by this, right?
Did you get an A last week?
I got two.
All right, I need my calculators back.